Objective: to discuss the different types of unit cells. Unit cells can be broadly classified into two categories: primitive unit cells and centered unit cells. All constituent particles of primitive unit cells, atoms, ions, or molecules, are present only at the corners, whereas in centered unit cells, constituent particles are present at various positions other than the corners. Based on the position of the centered constituent particle, centered unit cells are classified into three types: body-centered unit cell, face-centered unit cell, and end-centered unit cell. In a body-centered unit cell, all the corners are occupied by its constituent particles, and one particle is present at the center of its body. In a face-centered unit cell, constituent particles are present at its corners, as well as at the center of each of the 6 faces of the cube. In end-centered unit cell, apart from the constituent particles present at all corners, one constituent particle is present at the center of any 2 of the opposite faces. We know that a 3-dimensional crystal lattice is generated by the translation of lattice parameters A, B, and C. Based on lattice parameters, crystal systems are of 7 types. They are cubic, tetragonal, orthorhombic, hexagonal, rhombohedral, monoclinic, and triclinic. Let us examine each of them in detail. A crystal system in which all 3 axes are of equal length and at right angles to each other is known as the cubic crystal system. The possible lattices of this crystal system are primitive, body-centered, and face-centered. Some examples of cubic crystal system include sodium chloride, zinc blende, copper, diamond, etc. In a tetragonal crystal system, the 3 axes are at right angles to each other, but only 2 of them are equal. The possible lattices are primitive and body-centered. Calcium sulfate, titanium dioxide, tin dioxide, white tin, etc. are examples of this type of crystal structure. In an orthorhombic crystal system, the 3 axes are unequal but at right angles to each other. The possible lattices are primitive, body-centered, face-centered and end-centered. Rhombic sulfur, potassium nitrate, calcium carbonate, and barium sulfate are some examples. In a hexagonal crystal system, two edges are of equal length, two angles are of 90 degrees, and one angle is of 120 degrees. Primitive is the only possible lattice. Some examples of hexagonal crystal system include graphite, magnesium, and zinc oxide. In a rhombohedral or trigonal crystal system, the three axes are of equal length with equal angles of inclination not equal to 90 degrees. The only possible lattice is primitive. Calcium carbonate and mercuric sulfide are examples. In a monoclinic crystal system, the three axes are of unequal length, and only two of the angles are of 90 degrees. Primitive and end-centered are the possible lattices. Examples include monoclinic sulfur, and decahydrated sodium sulfate. In a triclinic crystal system, the three axes are of unequal length, all angles are different, and none of them is equal to 90 degrees. The only possible lattice is primitive. Potassium dichromate, boric acid, and copper sulfate pentahydrate are some examples.